Hey everyone, so the topic for today is Uber system design, right? Uber, Ola, whatever you call it. So basically, it's a ride sharing service, right? You can see my screen hopefully. So with every problem that we take, right, we first of all write the functional requirements, right? So please shoot whatever comes to your mind. So we would be requiring what? Passenger location, driver location. What else? What do you do with your Uber app, Uber, Rapido, Ola, whatever you call it? Request ride,
Yeah,
right?
accept or reject from the driver side.
Accept yes from the driver perspective, right? Okay. We'll write that as well. Let's say accept or reject by the driver.
Yeah, fare calculation, distance calculations.
Estimated fare, and estimated time from.
From system side. Okay.
What else? What else do you want to see? Helping, what else do you see in the Uber app or Ola? See what driver should be able to accept the request, right? This is from the driver's perspective, right? I'll just write this here, right? Accept or reject the ride.
Maybe real-time tracking, Pratik, once driver accept the ride.
What?
Real-time tracking, where driver, my driver is.
Yes, real-time tracking. So yeah, real-time tracking. Yeah, in a trip. Right? I'll probably move this here. Real-time tracking.
And then maybe payment is different, right? How
Yes, payment as well. We can write this, and then we'll kind of segregate them into let's say out of scope as well if there is anything in the out of scope thing,
hmm.
right? Payment.
And then user data like user rating, user
Yeah,
information.
card or cash, right? Yeah, user rating, right? Right. What else? Should be when he is able to accept the ride or reject the ride, he should be able to end the ride as well, right?
Hmm.
Anything else?
Uh, then the driver can also rate user, right? And
Yeah,
then
yeah.
user can
Now, when
rate
I say
driver.
user rating, both sides
Hmm.
basically based on the role they are in, right? They can actually rate each other, right? Then probably history as well, right? You may want to see
Yeah, ride history.
ride history. Ride history is one. Ride information also you can see, like let's say how much is the fare and all of that, right? For a given ride.
That's not come under the history part, Pratik, or
When I say history, it would be the list of
list when you click on the
records, and
details of this.
this would be a single record.
Hmm.
I mean, we can count it as a single only, whatever you say. Or let's say, let's keep this as a ride history itself. Or ride information, whatever you say. Ride info. When I say ride information, it would be ride or rides information. Let's call this as this way. Yeah. Driver should be able to update his location as well. Update his location, update his location. Okay, so I'll probably remove.
User can also cancel the ride, right? That option is
Yes,
also.
user can also cancel the ride in the sense, yes, correct. User can also cancel the ride. User can cancel ride. Okay.
Did not get like a driver's perspective, the third point, right? Driver should be able to update his location.
Yes, he should be able to update the location, right? I mean, wherever he is, right? Because what will happen is once, let's say, as from a passenger perspective, right? When you request a ride, right? I mean, if you, I mean, the system has to know where the driver is,
Okay.
right?
But that would be like something like
That is
automated, like
possible, no?
not in the control of driver, right?
I mean,
The third point.
yes, it's not in the
Just
control
my
of the
view.
driver, but correct. But his app is working, right? I mean, it's not the driver who is kind of doing this, but his app is the client, right? His app is like
Got it.
basically making a request. Yeah. So I'll probably cut from here, or I'll just remove this.
And then one more from driver's perspective, that navigation that integrated with Google Map or any other navigation engine.
I think that will captured as part of ride information, right? Because we are anyways passing the passenger location and driver location continuously.
Yeah, location we are passing, but which route the driver should take, that right? Shortest path or some lesser traffic path.
Correct, but see, we initially will get an estimated fare, right? The route and then the estimated time, all of that, right? But then at the during the ride, right? It's basically the driver who can even change the what do you call route, right? Okay, it's not necessarily like whatever the route it was showed to him, that only he takes. He can choose another route, and based on his distance that he covers, right, from the source to the destination, the passenger will be charged.
No, that is part of navigation engine.
Yeah.
So it is not what Uber provides, yeah, but it is integrated with another system, right? Navigation. So how Google navigation work, right? Suppose that
Uh,
if
yeah,
driver open that Google
correct,
navigation, then
correct.
he may be able to choose multiple paths. So one path he can choose, then maybe if
Yeah, I mean, so yeah, correct. That won't be part of the Uber part, right? That will
Hmm,
be a third party system, right?
got it, yeah, got it.
Not take this into account. Yeah.
And
Okay.
moreover, as a MVP, we can skip that also, I think.
Yeah. Yeah. Let's skip that for now, right? We'll quickly jump to non-functional, right? Okay. What can we have as part of non-functional?
Peak time handling, maybe
The system should be highly available, right?
AI available and
Okay. And then
traffic.
one user should not be, if you see, right, one user should not be getting request from multiple, one driver should not be getting request from multiple users. Right, so assume that I'm a driver, right? And you all are kind of requesting for a ride, right? And we are all in the same location. So what will happen is it should not be like I'm a driver and then you guys are requesting a ride, and I'm the only driver, and I get, okay, ting ting ding 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 request. Okay, this request is coming from Shubham, Amit, then Shamal, and that keeps on coming, right? Okay.
Means at a time a single request should come to driver, right?
Yes, right. So that is, how can we write that? Mhm.
Single
I
request.
think
So
that should
rights
be
are
more.
always queued, right?
Yeah,
Rights are always queued.
rides are always queued. I mean, that's how I mean, you will design the system, right? I mean, queued or not queued, right? I mean, that you are thinking that it would be done this way, right? But it may happen that, let's say we have designed like a very pathetic system, right? And I'm as a driver, everyone is kind of requesting a ride, and I kind of getting bombarded from everyone.
Something like prioritized synchronization, right? So
So
like
guys, understand
if
this.
he is having like a multiple request also, the one which has like a highest priority, if I'm booking a premier one, then he should be the premier request should get served rather than the other.
Guys. This is
Yeah,
not
this is non-functional, right? I mean,
okay. We are not
Okay.
discussing the solution here.
yeah. So, Pratik, one is like low latency system because I mean, riders' locations we need with a very frequent timing.
Low latency, where low
I mean, the
latency?
pings, the driver position pings.
The driver position pings.
I mean,
Uh,
where is my ride? That part.
correct, correct. Low latency while kind of requesting the ride.
Yeah.
Okay, I can write this way, right? The point that I was discussing, right? I mean, it was just coming to my mind that how can we frame that as a sentence, saying that one driver should be getting request from single passenger at one point of time.
I think, Pratik, you should put this one in this way. The driver should only allow to accept one user only. Okay, so driver can, receive multiple requests, but he can choose, right, only one, essentially one rider only he can accept.
No. That's not how it works. If you see any app, right, be it Rapido or anyone, right? I mean, all the request doesn't come to you, right? There is another way. I mean, if you see Rapido, right? Rapido users are able to see. Okay, they get ping, right? Okay, that if you've seen Rapido drivers app, right, or if you talk to them, right,
Now,
they, they
wait. So what I'm saying, so, my request arrived to a driver A, okay, and same time Pratik request arrive, right? Suppose my request arrived first, so
Mhm.
driver didn't accept.
Mhm.
Okay, so then your request came. So
Mhm.
driver might accept or may not accept. Let's assume driver accept. So
Mhm.
what I'm trying to say, the driver is essentially allowed to accept only one rider request. He can get multiple rider requests, but he will allow to accept only one rider request. The driver should not, accept multiple user requests.
Correct, but how if you see, right, the experience wise, right, it should not happen that,
So
see.
if you are allowing the feature like ride sharing or sort of, maybe you are allowing multiple rider to accept.
So
Yeah.
when I say my request goes to the driver, your request goes to the driver, right? I mean, if they are like, just assume that you're in a densely populated area, right? Or some concert is going on, right? And everybody is throwing away the request. What will happen? I mean, by the time you're trying to accept one ride, right? You wanted this, the other one is coming. Correct.
Okay. So I think we can think of this one is like incoming calls actually. Okay, so matlab, I think this feature is not that important actually. The number of matlab, rider are requesting to a particular driver is not an important. The important here is like consistency. The driver should not allow to accept multiple rider request actually.
Correct, that is true. My only point is, see, I mean, from the passenger point of view, right? Our passenger is much more important than the driver. Okay, I mean, driver is equally important, but then I mean, because driver is kind of part of the Uber family, right? But passenger is somehow not the part of the Uber family. Okay, so when the request is
Just
coming,
one question here.
yeah,
Thinking aloud, okay. Let's say I am requesting a ride. Now I will not wait or the user, okay, with respect to system design, okay. So the request will not wait until, if it is pooled to one driver, until he cancels it because of the fare reason or something else, or auto rejected after few minutes, and then it will go to another driver, and again he will take some time. If again request go to another driver, so you see the cascading effect. So the end result is, if um, the request is taking a lot of time, which means we are pooling this request across the nearest available all the rides. How will we handle this? This is not functional requirement, I'm just thinking.
Yeah, absolutely. Yeah. So this would be as part of, the low latency. We should quantify that, the rider should get the request as a success and failed at less than, certain time, maybe 30 seconds, 60 seconds, whatever, maybe. Not 30 seconds, like, at least a minute probably. That should be quantified as a, low latency for rider, success and failed. This is the quantified time actually.
So if you have experienced it, right? Okay, what happens in case of Uber, right? Actually, every request goes to a driver. They're given some 10 seconds, right? And then if he doesn't accept or it times out, right? Then only the request goes to another driver and so on. Okay. If you have observed the Ola behavior, so what happens is in 10 seconds, right? All the drivers gets bombarded with a one user request. Okay, so let's say there are five drivers and one request comes in, right? So all the five drivers will be given that request. Okay, now whichever driver accepts it first, fastest finger first, that user will, that driver would be given the request. Yes, in this particular case the driver experience is little bad. However, I told you the how the Uber one works.
No, Pratik, here the question was, okay, if
So
a
the question,
driver is not,
I
Pratik,
understood the question, so that's
once
why.
again, if driver is not accepting, 10 driver won't accept, right? So it is a cascading effect for the user for waiting for, infinite time, right?
That's what it's a experience, right? How you want to do it. So there are two different apps. They are doing it differently. As I said, Uber does this. Uber gives 10 seconds for the first user. If he- yes, the passenger has to wait, right?
So it is infinite time you want to allow the rider to wait. This is this is what you are thinking. I
Yes.
think I think you should specify, right? Within 1 minute, if no driver is accepting, we should respond to, the rider saying, there is no driver available or some sort of message to the, user.
So it's not infinite time. So first of all, like let's say five drivers are selected, right? And they will be kind of let's say based on the rating or based on the distance, right? The nearby driver would be sent the request first, right? The probability is that he would accept, but if he's not accepting, then only you will be kind of sending it to the next one, right? But if you let's say send the same request to all the five, let's say if I send one request to all 10, let's say you guys are all drivers, right? I send the request to all your drivers, okay? And then what happens is, let's say Samal accepts the right. What happens to the nine other? Just tell me from the user experience. You would say, yeah, the ride came in, but then somebody else kind
Yeah,
of.
I think you are not first of all not bringing the non-functional requirement, clearly actually. See, one rider request, okay, should go to one driver once actually. If he is not accepting, it will move to another driver. If he is not accepting, it will move to another driver. Okay, so even you are, transferring one driver request to two driver, you have to ensure one driver is accepting, not multiple driver. You should not allow to accept. So you need to
Samuel, why are
bring.
you not understanding this? Listen, I said there are two apps. They
uh,
kind of behave differently.
I'll pick this question. So someone he already answered. So somewhere we have to draw the line. So there is no silver bullet here. So we can have multiple logic. So like Rapido has this infinite kind of logic. Okay, after certain time, it will come back to you and saying increase your fare value. Maybe some driver may pick up. So the same thing in Uber, they don't have that system. But in Ola, after few request, shooting, they'll come back. So, different
No, no, that I understood. Different system has a different, requirement, right? So when we are presenting to the interviewer, right, we need to fix the requirement based on one or two use cases. There will be like, 100 apps will come up, 100 users. My essential point is like we need to somehow freeze the functional and non-functional requirement based on one or two use cases or two applications. Okay,
Yeah.
go ahead, no problem.
I think,
Right.
the generally interviewer will give you the liberty to choose. All that he wants to see is how do you take it to the end point.
Yeah, so let's say we'll discuss we'll stick to Ubers, right? Where one driver will be getting 10 seconds to accept a ride. If not, then the request would be forwarded to the next one. Let's say the next eligible driver. Okay, let's move on.
Pratik, just one thing. Ye
Yeah.
wala, this should come into functional, right? Not in non-functional.
One driver should get.
This will go to functional here.
Yeah, you can put this in function. Yeah. Okay, this is 11. Okay, cool. What else?
Availability is scalable.
Item potency we need actually because
Yeah.
payment is involved.
Yeah, idempotency is required. Okay, and idempotency in terms of the request as well, right? So let's say, I mean, let's assume that the way Ola operates, okay, let's say what happens is the microservice kind of sends broadcast it to, let's say, 10 users, right? And let's say one of the user kind of one of the driver accepts the ride, right? It should not happen that the other driver the ride matches with the other driver as well. Yeah. However, this will not happen in case of Uber.
We need strong consistency also here because
Yeah.
we will scale this up also.
Okay, so depends from where availability, where strong consistency depends. So basically, available means basically the system should be available to take the rights, right? In terms of when I say strong consistency, that means what? One user should be tagged to one request only or one driver only, that way. Okay, cool. Anything else, guys? We can discuss durability as well and all of that.
There should be some data data related to, like suppose there is few drivers that are canceling a particular user's request. The request shouldn't go to that particular driver again. So we need to store that. So data retention also would be required, right, for every request.
I really did not get that point, Irfan.
I mean to tell, like, let's say there are 10 drivers whom my request is going, like one after the another. So if a driver cancels my request, the same request shouldn't go to the same driver who has already cancelled my request.
How will it again go to the same driver?
Yeah, so you will have to know, right, so that you don't send the request to the cancelled driver. Else the system would again like keep sending if you put it in a queue or some.
That's obvious, man. See, I mean, the thing is, if one request is being sent to, let's say, 10 drivers, it's not that one. I mean, it would have to keep correct. It would have to keep. Let's say they are. Let's say this is the first driver that I would be sending. Then this is the another driver that I would be sending. It's not that the request. It would be broadcasted to the same person again and again. I mean, that's obvious. Okay, let's not get into it.
Okay.
But no, Pratik, his point is right. Suppose that driver first accept the request, right? And then suddenly he cancel that ride within a few milliseconds or few seconds. So
No, that-
again when
No. That does not happen. See, when millisecond in the sense, see when you accept the right, you are in a trip, right? You are in a trip, right? And if you are if you're on a trip and if the driver cancels, then the trip is cancelled.
No. Sometime you in Rapido you see, right? Once the driver is canceling, it is saying I'm searching another driver. Right? On
So,
on the
Amit,
right
I
here
think
you saw this message.
Amit, I think let's focus on the Uber part only right now, because all those things we are discussing are part of functional anyway. And if you want to keep it, then let's keep it. But
Yeah, let's
let's
keep this
focusing on.
out of scope. That is fine. Yeah.
Because see, I mean, it's like, how do I say, man? I say like it's like you're saying that I am looping on 10 items, right? And again I loop that same item again. I mean, it does not make sense. Okay. I mean, I would go with a simpler system where I'm kind of sending the request to users. Why will I again send to the same driver? Obviously, there will be a basic mechanism to kind of do that. Okay. So let's say we'll keep this to be 6 months. Okay, for the history and all of that trip information. Okay. Uh, so guys, functional requirements we're done, non-functional we're done, right? Just in case if there's anything missed, to let me know, right? Otherwise, we'll move to. Yeah, go ahead.
Security side. Are we taking security requirements?
No, man.
Right? Yeah. Got it.
We'll keep that to be out of the scope. Yeah,
Correct.
good to play.
It's complicated.
But we can keep that to be out of scope, right? In fact, the payment and monitoring analytics, we can all count that, we can all write that, but probably we can say out of scope at the moment. Yeah, good to specify for the interviewer thing, but we have to be very quick on it. I'm a little rushing because there are a lot of things that we have to cover and we're already out of time. Okay, analytics, monitoring.
I think one point, Pratik, I am thinking of maybe like the throughput, right? Is it little bit something you want to add as non-functional requirement?
Yeah, I think throughput of what with service.
The search time, right? Search time, maybe some large number of requests can become, right? If it is newer or some kind of event, right?
Okay. Okay. Yeah, we can say that we can probably accept, let's say, some number of writes that you're saying. Yeah, we can define that, right? Okay, as part of, let's say, what? Let's say our daily active users, right? We can keep this to be as 1 million, right? 1 million daily active users. Okay. And let's say drivers would be how much? Almost close to that number, right? Probably slightly less because not everyone would get a ride. Okay. And what else? So we'll say that what will be accepting what when I say 1 million divided by what 86,400, right? Or let's say I keep it 1 lakh, which is 100K. Is this 100K? Yeah. Okay, let's say this is 1000K basically. If I divide, then that means almost 10 writes per second is what I would get.
I think calculation wise that is okay, but I think DAU would be a lot greater than driver count, I think. What do you think?
Is it? I mean, you tell me.
I mean, drivers are fairly less than number of riders.
Yeah, I mean, as that's what I said. They would be slightly lesser than 1 million, right? Not 1 million exactly, but it would be.
I was imagining some tenfold kind of number, like 10 million and 1 million.
I mean, I was
But
thinking,
okay.
let's say we say 80, right? 0.8 million. Okay, I don't know. I mean, I really do not know the
Sure,
numbers.
sure.
We can Google them, but let's, for the interview sake, let's keep with these numbers as approximations, right? And we'll,
Yeah.
yeah. Okay. Okay. So we have kept these out of scope. Yeah, by the way, one more thing, right? Notification is one that nobody talked about, right? Driver should get notification, right? So basically, why I'm saying is because we'll have to bring in the notification service as well, right? Okay. I think we talked about it, but we did not explicitly write it. Driver should get notification of the what? Of the ride request. Yeah.
Calling function is also there, right?
What calling?
No, when we can able to call the driver or he can call them.
No, please, let's not keep that. See, as part of the once the trip is kind of confirmed, right? I mean, we'll assume that the numbers are shared, right? Because those are part of the user profile. Okay.
Okay.
I mean, guys, understand. Okay. Understand what is the objective of this problem. The objective of Uber system design is not notification. Uber system design is not the massive calculation, but what the interviewer wants from you is that how is the rides matched, right? How are the users, how are the drivers calculated, the nearby drivers. So all, I mean, we have to move in that direction, not like we take small features and keep discussing about it. I mean, we can, but understand what the problem statement is, what is that the interviewer wants from you. Okay, so this calling is not at all as part of this problem statement. Okay. Okay, let's go to API, guys. Okay, now what APIs do we have? So let's say when I say what, I would request what, request write, correct? What I would do, I would say start location and end location. Okay, I'm just writing the methods to make it quick. Otherwise, you can write it in the API way as well. Okay, what else?
Fair estimate.
Yeah, get fair estimate. Okay, get fair estimate. Get what? Time estimate.
Drive.
Okay, and let's say I see get route as well. Get fastest route. Okay, these are all with start and end location. Okay, what else?
Driver APIs are also there. I mean, accept, reject rights.
Yep. Accept or reject or end trip, right? Or start trip.
Then we have payment APIs also.
Yeah, payment APIs as well. But we'll guys, we'll just keep this to be out of scope at the
Okay,
moment.
okay,
Yeah.
fine. Yeah.
What else? Rate user is one. Okay. What else?
You included. We are not including riders location. I mean,
Yes,
drivers location.
we say update location, let's say. Okay.
Sure.
And so this would be user token that would be going inside this, right? Okay. And my location. Okay. I'll say lat long. Let's say lat long. Yeah. So it can be a user, it can be a driver, right? So let's say when the user token is sent, right? The role would be anyways there in the user profile, right? So that way. Okay.
Do we need user location once request ride get confirmed? The fast API, right, where the user will provide the start location and end location. So I just want to understand like why we need, lat long of user once the ride has been, done.
Yeah, makes sense. See, when the user is requesting ride, and as long as the trip is not starting, right, I mean, probably let's say the user moved from let's say 100 meters to let's say 500 meters. That may be used, but I think this is always a problem, right? So we'll say update location, but this will be only for the driver. Let's say. Just guys, anybody countering this?
Yeah, yeah. No, no, I understand. But just one thing, just instead of since a ride is already created, we have a one concurrent transaction. We already have the driver's ID, so we can pass driver's ID instead of user token.
Um.
What do you think?
So
Because it's a yeah.
good point, but what happens now?
Because these details are fetched from the transaction only, no? And
Yeah,
that
correct.
object.
Now what happens is, see, when you are making a request, right? Anyways, the header will be going from the user token. Basically the user token would anyways be going, right?
Yeah. Anyways, it will go every call. Yeah.
Correct. So let's say, then isn't user ID or a driver ID redundant? Because I may mock somebody else's, right? Let's say, or you are saying that user token is not there. So then if I just in case if I have a driver ID and let's say I'm a hacker, right? And I can let's say pass Shubham's driver ID and along to update this API.
I mean, you can just to keep things simple. I just told like.
I would say user token would be the right way to get
Okay.
this updated. Yeah.
Sure, sure. Let's go on.
And unless you have a valid argument, you can
No,
come.
no, Pratik, yeah, that's true. Pratik, I just want to understand one more point. This update location, right?
Mhm.
So is it like for what purpose like we are getting this lat and long actually?
So basically what happens is once the user switches his app, right? Let's say you are a driver, right? And you are there, let's say sitting idle or let's say sitting at a bar. Okay. Now and you are not interested in taking the rides, right? And you say that you have turned off the app, right? So then what? There's no point of continuously sending the locations to the driver because sorry, to the server. Why? Because when the actual request comes from the passenger, right, the server really wants to know who are the drivers and where are they. But
Yes, that's true. So then it is very specific to driver location, right? The update location
correct,
continuously we
correct, correct.
wanted to
And that's what I
store.
said. Update location, and this is only for the driver. Yeah, will not
Yeah,
go with the passenger.
right, right.
Oh, that user term is confusing. So can we say driver token
User token is that this will go as part
or
of
API
header,
with user token? Yeah, yeah.
right? Every request would have a user token. I have not written that explicitly, but every request as part of the header, right, will have the use this token. Okay. So see, when you log into Facebook, right, the first time, you basically enter the username and the password, right? The server authenticates you, right? And then it let's say sends you the JWT token, right? And then the subsequent request that you make to the server, right? You're not sending the username password, right? For every profile you are going to the marketplace, you're going to play the videos or anything, right? You are not, because what happens is in the background in your headers, right? Whatever the API that you're calling, right? The user tokens are going. And this user token here is whoever is calling this API. The driver is calling the API. He's updating his location.
Yeah, so first of all, we are not supposed to send, either it's a driver or user, their timestamp or their, ID related information not part of API. It should be passing, as part of, session or JWT token itself.
Yeah, so as I said, this is header. This is part of the header. Okay, this will be part of the header.
Oh,
Okay.
okay.
Okay. What else, guys? We have accepted tribe and all that.
Yeah. One more point. I think you included this rider information, that ride trip information. I think.
Trip information. Yeah, yeah. Get trip information. Get trip info. Okay. So then user token would be sent, right? And let's say the trip ID would be let's say an optional parameter. Otherwise, when you say user token is only passed, then you get the entire trip history. Yeah, for the last 3 months. And you'll have to obviously paginate this, right? Okay. Anyways, cool. Guys, we are not yet started with the main thing. Okay. So this is where we have come, functional, non-functional APIs, right? Okay. So now as part of this, another thing that I want to bring in as a section. Okay. Um, okay. When I've called these APIs, right? Uh, I've not talked about this in earlier sessions, but I want to just group these APIs into multiple microservices as well. Okay. Okay. Now, these will be some of the services which we can think of, right? One would be a map service, right? One of them would be a payment service somewhere, right? Sitting. Okay. What else? Analytics service, correct? What else? Location update service, right? Now all these APIs, right, or multiple other APIs would fall under these categories only. Yeah. What else? Any other service that you can think of? Tell me. What are our use cases? The passenger would be requesting a ride, right? Correct. He'll have to find out the drivers who are nearby, right? There would be some service, ride matching service. Correct. Map service is fine. I mean, this will probably give you the estimates, the fare, the time, the route, and all of that, right? And loading of the map, right? But the main logic would be here, right? What else? What else, guys?
I think history service and all would be there, but I think let's focus on this match
Yeah,
riding service
one
maybe.
user service I can think of.
Yeah.
Yeah. History service. Can this fit into anything, right? We can say trip service, right? Trip related information. Yeah. Anything else? No? Okay, cool. Now we'll come to another section called core entities. Okay. If you have watched multiple other videos, past videos, or other system design resources online, right? I mean, this is also one section, right? Basically, the purpose of this section is to, at a high level, think of what are the things that would be involved in the entire system design, right? Okay, so we really do not have the clarity at the moment, right? We really do not have the clarity at the moment, but we are just throwing that what are the things that come in, can come as part of the entities. One would be a driver, one would be a passenger, right? What else? These are
I mean,
entities.
both would be user only, user extendable. Your
Correct. Both of them would be user only. Yes, correct. Makes sense. Yes, this will
then
be either correct user, right? This is actually user entity, but either will be driver or passenger based on the role.
yeah. Then
Yeah,
the ride maybe the ride also we need a ride
ride
table.
or trip, whatever you can call it,
Trip. Uh,
right? Location is also one important thing that is playing. Okay, because I mean everything is all about location here, right?
You want to store this in the database.
Yes, location will have to do store. Location we will have to.
I mean, it's a stream of data, right? I mean, Is it required to be
Stream of
stored?
stream of data, but let's say when you until unless you don't store that, right? And let's say and the user is requesting for a ride, right? You have to know where is that user. You have to take some action, be it in memory, be it database, somewhere you'll have to store. Based on that only you'll have to that ride matching service will have to take some action on it, right?
GPS
I thought
coordinates can be stored in that, right? GPS coordinates
The GPS coordinates where?
and the location of that user.
Correct. We can store that in the user as well, right? We can store that on the user as well, but I somehow feel that location is not that simple, okay, that long, okay. So that's why I pulled this out from the user.
Pratik, I'm not able to understand this. So location, is it really required to store? It's a real-time data we need to pass on to the user, right? I mean, is it required to store it? Because there would be a lot of junk data, we really don't need it.
Correct. I mean, we will have to store, let's say, be it trip information as well, right? I mean,
Uh-huh.
let's say you have traveled from some X distance here to here, correct? Okay. Now, what may happen that you may not have to pass it for every second, or like let's say if you're passing every second, that need not be there, right? But that stream that you're passing, right? Let's say you may have to batch all of this into one, right? Let's say I was ordering something from what do you call today with from Swiggy. Okay, so what happens is how the ride was kind of how the this delivery partner was moving was that he was here, and then what happens is automatically his bikes jumps from here to here. Okay, then his bikes jumps from here to here and from here to here, right? Obviously his app is actually sending the actual coordinates, right? But then there is some system who is actually kind of aggregating them and then making one point of it.
Correct. So, okay, understood. So then we might need to store it in some in memory something, because otherwise it will. I mean, it's difficult to scale this actually. Then
Correct.
we'll store in some in memory.
Yes, because there is so much of data, right? I mean, we will
Correct.
only have to use what is relevant.
Q, I think. We need to use Q or something, right?
No, not Q.
Okay. Cool. Yeah. Okay. Cool. Now let's come to the next section, which we call as high level diagram. Okay. Now, as part of high level diagram, right? Basically, the expectation is that we kind of present a system to the user, to the interviewer in such a way that it gives the interviewer a fair idea, right? And once that fair idea is given to him, right, then we will kind of deep dive into each of the sections, saying that how this service would work, or how this feature would work, or let's say we want to dig deep into any of the functional requirement or the non-functional requirement, we can kind of move on from there. Okay, cool. So as part of this thing, right, there would be some API gateway here. Okay. Okay. So guys, this is our fare estimation service. Okay. I'll call this as fare estimation SVC. Okay. When I say fare estimation, it is also calculating what? Fare estimation, then time, and then the fastest route with the help of some service, which is, let's say, called as a map service, which can be an external party as well. Okay. What else? One would be a ride matching service. Yeah. What else? Payment service. Payment or billing service, you can say, right? One of them would be a user service. What else? And one I'll keep as a notification service. Any other service that you can think of. Guys, I introduced this section so that we have a clarity here, right? From the APIs itself, what are the services at a high level that we will have, right? Based on it, we can actually draw the boxes. Okay. This will be our load balancer plus some API gateway. Okay.
Pratik, before this HLD, in normal interviews, we do check the database also. No? I mean, what all databases we'll use and all.
So I won't say that. I won't say ki you talk about the database, right? As part of HLD, we will also put some database, right? I don't know which database at the moment. Okay. So let's say we keep some kind of a database here, right? And we'll probably put a caching layer here at a high level. Say that this is a caching layer. Okay. Basically, high level diagram here is that yes, we will dig deeper into it, but yes, we will dig deeper into it, but this is at a high level, right? How the kind of flow and all of that would work. Okay. I'll not draw the arrows probably, right? But essentially these are all pointing to this cache layer, and there is some database involved here. Okay. This is at a very, very high level, right? A kind of a helicopter view. Okay.
It's 22 hours.
We are not there yet. Okay. We have not discussed any flow, but at a high level, this is what mind map of the entire system would be. Okay. Now,
Pratik, okay, maybe I'm not sure actually. My question is will be valid or not. See, this payment service and notification service, right? Is it really like to be mapped to caching layer? Even in case of HLD, like how that how that related actually.
so guys, see, I mean, we really don't know, right? This is at a very high level that I'm talking about. And in fact, these notification and payment service are actually not part of are not in fact part of the design altogether. Okay, they are a different system. And yes, payment system may have its own caching layer, right? Notification system may have its own caching layer. User can have its own caching layer. What we are kind of interested is in basically somewhere here, right? In fact, user service is also like just to get the user information, if he's a driver or he's a passenger, right? I mean, if you want to keep this out of here, I'm completely
I think you should remove because it is deviating, the core problem what you are trying to solve it.
Yeah. Okay. I'm completely okay. I don't deny that fact, right? I'm completely okay. But you can still include this in the as part of the system, saying that this will be somewhere like this, right? These are your main services, and these are the other services which would be used. Okay. Yes. Obviously, they will all go through the load balancer here. Okay. I'll copy this again. Now, the next section that we will be talking now is basically the deep dive. Right? Okay. Now we will be discussing how our fare estimation would work, right? How a ride matching service would work, right? How our functional requirement would be mapping, right? Or what services which would be taken care. Okay. So if I talk about fare estimation service, right? Okay. If I just zoom on this, right? Fare estimation service. So basically it will have what? It will have its own API gateway and load balancer, right? Okay. And there'll be multiple instances of this, right? Correct. And then ultimately it is what? It is basically calling the map service, right? Which would be our third party library, right? Because we really don't want to get deep dive into it, right? And if you remember initially as well, right, Ola or other these providers, right, what essentially they were doing is they were basically using other libraries like Google Maps and all of that, and a lot of cost was going in that itself, right, as part of the infrastructure cost. And later on, like Ola kind of developed their own APIs in order to cater all of this fare estimation, then what the route, then the distance, right? So basically, it's the passenger who's kind of requesting the ride here, right? And this is the API gateway, right? The request comes to this, and you are not kind of involving any of the driver location or anything, right? Basically, it is taking the source and the destination, and you are getting basically the you can either kind of what do you call this as a map service or an estimation service, right? Instead of just calling this the fare estimation service, you can call it as an estimation service, right? Basically, when is this called? I mean, even if, as far as I remember, right, you give a source and a destination, right? And at that point of time only, it fetches you the how much time it would take, how much the fare it would cost you, and also the route, basically, right? So this is the zoomed view of this. Any questions, guys? Now, how is fare estimation being done? How is fare estimation being done?
Based on source and destination.
Wow, what answer.
I think we need some kind of algorithm here.
So guys,
Register or something maybe.
yes,
And
correct.
the distance.
So let's say this is your source and this is your destination, right? Let's say if you guys are in Bangalore, right? Let's say you're traveling from Marathalli to what, or let's say you're traveling from Electronic City to Whitefield, right? Two ends of the Bangalore, right? Okay, I'll call this. I hope you know where Electronic City is, where Whitefield is. Okay.
We have to basically see which path the shortest path, basically, whatever the algorithm takes. Based on that, it will be calculated.
Correct. The shortest path it would take, right? So what you would have to do. So basically, every request comes in, right? You see that okay, the shortest path is right, and you will get into a shortest path algorithm, right? What is the complexity of any shortest path algorithm?
Dijkstra's algorithm is there, right?
Yeah. What is the complexity? Thing n cube, right? Dijkstra's, Bellman-Ford, A star, whatever you want to apply, right? But you're saying n cube, right? For what? For every request. For every request. And you're saying there are 1 million users. What then? Is it really optimized? Would you be able to scale it? No, that won't work, right? So what really we have to do here is, what actually essentially happens is, so these, right, these kind of the entire map, right? Entire map is divided into multiple subsections, right? So let's say this is what you're seeing, right? Okay, let's say they're from let's say Marathili to Whitefield or what Electron City to Whitefield, right? These are the three routes that you have, let's say, suppose, right? One has a high drive, one has a high traffic, the other has a flyover, and the other is like through some narrow lanes, right? And bumpy roads, correct? So the entire map would be somewhere divided into like this, right? Now what happens is, one way is that every time we calculate the shortest distance and then we add the factors to it, saying that mm, okay, what would be the kind of distance and then the fare, right? That is one way in the real time, right? But the other way is we may pre-compute as well. We may pre-compute few of the things, right? Few of the things in the sense, let's say if I know the distance from here to here and from here to here and from here to here, right? And if somebody is asking me the distance from here to here, right, this final position, what I really have to do? I really have to sum three numbers, right? Correct. Like let's say if you're talking about the distance from here to here, right? So probably we'll say, okay, which are the cells really involved, right? And we can probably say that, okay, these are the three routes that are there, but let's say the shortest time that it takes is probably in what will happen is these will be summed, correct? This will be summed, this will be summed, this will be summed, and we get a number quickly saying that this would take, let's say, 17 minutes, this would take 15, and this would only take 10 minutes, right? And that's how the computations would be done. Okay, in real time we won't be calculating the shortest path, right? And yes, it depends, sometimes traffic and all of that, right? There are a few things computed, right? And there are a few things which are kind of somewhere in real time as well, right? But all this can still be managed because this is more of an approximation, right? But it should not be like slow, like otherwise the whole point dies, right? Okay, I mean, before even we request the ride, our objective is to know what is the estimated fare, what is the estimated time, right? So this is what we would do. We would there would be few things pre-computed, and we would just add them up to know the final value. Yes, I know this is not straightforward like summing it up, right? But the idea is this. Okay.
Yeah,
Cool.
Pratik, one thing. So this, computation as part of your fare estimation service, or is it part of the external map service?
So basically what would happen is this is the service, this is the estimation service, right? There are multiple parameters which are coming from this map service, right? And it depends. I mean, I'm not very sure that where it would lie, right? But if map service is able to give, right? If Google Map is able to give this, right? Ideally, the Google Map service should be able to give us this, right? It will not give us the fair estimation, but it will give us how much the weight of each path is. Like, let's say how much of the weight of this path is. Let's say if this is really red, right? So this would let's say take 10 minutes, right? So what would happen is I would have some weighted factors for it on our estimation service side, and we would multiply that and get the final summation done. Because Google Map we will not be able to tell us, right, what is our those base factors we'll have to multiply. Okay, I mean, see guys, this is a very complex system. Whoever is working in Uber, or not just one person, I mean, even not one person would know, right? I mean, there are people who would be specifically working on this, right? They would know the core of this, right? Our objective is that what would be the main idea behind this calculation. That's what I wanted to bring out. Yes, it is definitely, this will be definitely much more complex that we just discussed. Okay. Any questions, any doubts before we move on?
Not a doubt, but just a thing like if a map service can return the time taken for the entire trip from source to destination, like multiple trips, like let's say 1 hour, 10 minutes, 1 hour, 20 minutes. If we just know the time taken for the entire trip and few parameters like is it weather conditions and the traffic, we can just do a fair estimation on that. Will
Correct.
that also suffice, right?
If you see, right, Google Maps itself, right, if you put a source and the destination, it actually tells you the time, right?
Yeah.
Yes, Uber can use that straightforward.
Okay.
Or it may directly be multiplying the entire time with some factor. I really don't know. But it will not be just the time, it will also be the distance.
Yes.
Okay. Cool. So that's what part of the estimation service is. This is fair, fair, distance, and route. Yeah. Hey Pritesh, please mute yourself if you're not speaking.
Oh, sorry.
Cool. Okay. Then we come to the right matching service. This is one of the most important one, guys. Okay. I need your time and full focus and full attention here. Okay. This is the main one that we are going to discuss. Okay. So basically, this is the service, right, where the flow is that the user is actually requesting a ride, saying that here is my source and the destination, right? Okay. Give me give me all the available riders. Sorry, available drivers. Okay. Now, for this service to know where are all the drivers, all that location should be actually updated. Okay. So guys, before I get deep dive into it, right, I would like to bring in few concepts, right, which will be important for this ride matching service, which I'm going to discuss now. Okay. So what I'm kind of coming to is ride matching service. Okay. Basically, this as part of this, right, as I said, I really need to know our problem statement, or the problem with this service is that you are given some location, okay, some latitude and some longitude. Okay. Okay. Latitude. Okay. This is our input actually. Okay. Now the problem is that if when you're given this latitude and longitude, right, what you have to do is you basically have to find all the nearby areas, right? All the nearby areas where these drivers are. Let's say our latitude is X and our longitude is Y. Okay. And I say that, okay, what I do is I say X plus 2, okay, and X minus 2, okay, and I'll say Y plus 2, okay, and Y minus 2, okay. This is the region that I would find all the drivers. Okay. That means basically this is my coordinates, and here is my some point X comma Y, right? So what am I saying is X plus 2, right? Basically this side and this side. So that means what? This is my X plus 2 somewhere. Correct. Okay. And this is my X minus 2. Okay. And similarly, my Y plus 2 would be somewhere, let's say here, right? And Y minus 2 would be somewhere here, right? Basically what I'm saying is the passenger is standing here, and we want to find all the drivers which are in this location, inside this box. That's the problem statement with the ride matching service. How can we do this? Okay, so let's
I
say,
mean, we can do the same approach we did for fair estimation method, like the geo tables we have, right? Like in the Redis and all.
Mhm.
that we can use, and they will give us the nearest point location. I mean, nearest points if we give some radius to it.
Nearest point. I mean, see, there are some drivers here. Okay. Now, how do I kind of search between these all the drivers? So let's
I think red. Okay, yeah, sure.
Nice, good, good, good.
So yeah, I was saying like the Redis, we already have this geo index store, right? We can take help of that, and given a point, which is the point of the requested rider, we can get back the location of the nearest, because anyway we are storing driver's location above, right? So
Okay.
from using that, we can do that.
Okay, cool. So there is what Shubham is saying is something, a feature in Redis, right? Okay, which can somewhere help us, right? But before that, forget about Redis, forget about any other system, right? Let's say this is a two-dimensional data, right? How would you find out in a database? What will you basically do? Let's say there are 1 million records, right? What you would do? You would say that, okay, give me all the records between what? These two lines, which is let's say till y plus 2 and y minus 2, right? And let's say out of those 1 million records, you get, let's say, 100 records, right? And then those 100 records would be passed onto another filter, correct? Another subquery where basically this would find between what? Between x plus 2 and x minus 2. Why? Because it is a two-dimensional data, right? I mean, you'll have to pass this. If this is how I mean every problem is solved, right? So that is, I mean, this can be done, right? We can do it, but then this will be really time consuming. I mean, this is not fastest, and as we said, right, this requires a low latency. Somebody said, no, it requires a low latency while requesting the ride. If we do this for every ride, I mean, we are also locking the table, correct or not? Right? You're reading through 1 million records
Can
every
you, Pratik, can you explain? Sorry, can you explain again, please?
Yeah. So let's say what happens is, let's say we have some records. Okay. I'm not able to draw a spreadsheet. Let's say there is this record, this record, this record, this record, this record. Okay. These are 1 million records. Okay. So now what happens is, now what happens is you say that, okay, I give me all the records. So
No, no,
basically,
1 million what record? The driver location record only, right? No, what do you
so
record means what?
these are locations, right? These are multiple locations where where drivers locations are stored.
Yeah, essentially the driver location, correct?
Right, driver locations, right?
Yeah, yeah.
Okay. So now you're saying that give me, filter out only the records which has, there are two columns. Let's say one is lat and the other is long. Okay. Sorry. Let's say one is lat, right? One of the column, latitude, and the other is longitude. Okay. Now, so what happens is, as you say, let's say latitude, right? So when you say latitude, it's actually, let's say we'll talk about axis, let's say suppose, okay, you are requesting that between x minus 2 and x plus 2, give me all the records, right? So let's say after that filtering, what you got is, out of this 1 million records, you only got these 3 records, let's say, or 100 records, these 3 lines out of these 5 lines, right? Now once that is done, you have to pass to another filter as well, right? Because yes, these are between 2 lines, but these can be here as well, na? Correct or not? But what you're interested in is, yes, between these two, but between these two as well, na? These 2 lines. Correct or not? There are 2 sets of filter, right?
This is for to provide the driver location, right? This
Yes, to filter out the eligible drivers.
Eligible driver, right.
Right. So this is going to take a lot of time, right? For every request that you're doing this, right? Scanning all of these records, this is going to break. I mean, break in the sense this would be.
Yeah. So Pratik, what I understood, like x plus 2 is like, the radius, right? You are doing, ahead of 2 kilometer and behind of, driver, maybe the forward and backward, right? That is plus 2 and minus 2, right?
Yes, yes, yes. So basically 2 kilometers. I mean, this
Mhm.
passenger, right? This guy is standing here. This passenger.
Hmm. Yeah, go ahead, go ahead. Yeah.
Yeah,
No need to.
this guy is standing in the middle here, right? Now, what we are basically saying is both, right? He's in the center actually. Correct. So we want to find all the drivers near to him. That's the purpose. Okay. So that's why two level of filtering will have to do, and then this will really slow down the system. What do we do for this? This is the challenge with the right matching service. This will work, but the problem is this would take a lot of time. Right? So now what happens is there is a data structure called quad tree. Okay, you guys must have heard of it. Okay, now what quad tree is? Quad tree is nothing but just a, yeah, Shubham.
Sorry, Pratik, just 1 minute I'll take. So actually, I had this question in like some years ago in one of the interviews. So there I gave an answer. I mean that worked out actually. So I just want to iterate that also. So what we can do here is we have the user's location, right? That is long lat, right? And obviously every ride matching service they have one parameter of in like 300, 500 meters or maybe 1 kilometer or something, right? So obviously we can create one geohash kind of a method, like which will take the long lat, convert it into geohash, because anyway that's exactly what you were also doing. Like in cubes we are dividing, right? And you also have drivers API, drivers long lat also. So drivers long lat are also converted to geohash. Your location is also converted to geohash. In that same geohash, if there are multiple drivers, we'll send out these pings to those drivers only. And anyway, since the driver locations are also constantly updating, every time it gets calculated a geohash, and I mean, let's say you store in memory or something, fast memory, and this way you can match it.
Cool. I'll come to the geohash as well.
Yeah.
Okay, don't worry. So basically, guys, quad tree, right? This is one of the data structures which is widely spoken, and I would say that this was the first initial implementations of Uber where these things were getting calculated, right? Now, what is a quad tree? Quad tree is nothing but basically what happens is if you have this space, right? Okay. Now what happens is every space is actually divided into 4 parts. Okay. So imagine this is a earth, right? Okay, you have the complete earth, you have put it into a map. Okay, now every space is kind of divided into 4 parts. So this cell would be something like 0 0. This would be 0 1, right? This would be 1 0, and this would be 1 1. Okay, now oh God, sorry. Okay, so this space is 1 1, right? Now what happens is this thing, now let's say the entire earth is now divided into 4 parts, right? Now what happens is, again, if you want to divide this space, right, this is again divided into 4 parts, right? Where the base is 0 0, this will be what? Now this will be 0 0 0. Okay, this coordinate, right? This will be 0 0 0. Then this will be 000, I mean, sorry, sorry, 4 digits now. This will be 00. Okay. Then this will be what? 0001, right? This will be 0010. Okay. And this will be 0011. Okay. Again, this would be again divided. Another 2 bits would be required, and so on. Right. So what happens is every piece, right? It is actually converted from a two-dimensional to a one-dimensional digit. Okay, so if I have to pinpoint this region, right, this would be given by some digit, right, not 4 digits, but since our earth is so big, right, probably some 64-bit would be there, or some 32-bit would be there, and then you will be able to represent that point by that digit. So that would be, so what happens is, you can say that, okay, this is the lat long, right, there would be some box, right, some black box, right, converter, right. What that does is, basically, you pass in the lat long, right, you pass in the lat long, and this would convert you to some 32-bit this thing coordinate, right. Now this is easier to find, right. Now what's the problem then? This also has a problem, right. Now how is quadtree stored? Quadtree is nothing but quadtree is one kind of a B tree, right? What is a B tree now? Okay. In short, guys, you know a binary tree. B tree is nothing but
Left tree and right tree.
no, Pritesh, don't be so quick to answer. See, B tree is how do I say? I mean, this is nothing but an M array tree. Okay. So when I say M array tree, right? I'll not go deep into it, because what happens is it combines as well and then splits as well. So all that I'll not get into deep into it. That's altogether a data success session. I mean, I've taught to my students in the past, but then you can consider saying that if it is an M array tree, right? If it is a quad tree, right? So what is happening is every node, right? Every node is somewhere having 4 children. How this is stored is that every node is having 4 children, basically, right? So if I say this coordinate is kind of let's say what we had, what this is 00, right? So then this will be what, this will have 4 children as 0000, right? Then 0001, right? And then 0010 and 00 and 11. Yeah. Cool. Okay. Now again, when you split this, again it will be divided 4 children, 4 children, 4 children, and we will have a massive quad tree. Right? So if you go to multiple resources online, they will, lot of resources will say that quad tree is used in Uber, because we really don't know, okay, what Uber is internally using it, or in fact it was somewhere, some point of time you was using quad tree, okay, but that's not the case right now. Okay. So point is that when you have to search like this, right? Okay. And let's say if you want to find the nearby locations to this cell, right? What you can do is there will be some prefix, right? Let's say all the n-2 bits will be same, but the last 2 bits would be different, and we would get all the nearby cells. Right, all the nearby cells, and we can get all the drivers with those cell IDs. Just imagine, like, let's say if you have 00001010101, some cell ID like this, where actually the passenger is standing, right? So what you can do is, okay, you'll say that, okay, just remove these two bits, right, and get me all the other combinations of this, right? So this, which is 00, right, 0001, right, 110 and 11, right? And get me all the drivers in these cell IDs. Yeah, yeah, Shubham.
Pratik, in my opinion, this is more expensive actually.
I will come to it. I will come to it. This is not the optimal solution. I'm so sorry. I mean, that's what
Correct,
I
correct.
had to talk a lot in Uber. That's why I didn't want to spend too much time, and that's why I wanted to move fast. Okay.
Okay. Understood.
Okay. So, guys, this is what quadtree is, and this becomes massive. Okay. Now, when we are saying that we are in a distributed system, right? This creates a problem, right? One machine may not be able to store the entire thing altogether. Okay, there are multiple courses that have referred, right, and multiple resources that have referred, and they say that this would be stored in a system in memory, right? But this is not that easy, right? Because the earth is not that small, the earth is so big, right? Or probably they can divide it, right? I won't say the entire quad tree would be stored at one place, but what you can do is, you can probably, let's say, divide this quad tree based on the region. Let's say you are in Bangalore. Based on your Bangalore city, there would be some quad tree, right? Based on Mysore, or based on Delhi, or based on Noida, you would have your own quad tree, right? So that way, so you need not really have a, let's say, 1 million level of quad tree. Okay. Now, so another, jumping onto this, right? So basically the storage of this, right? This also grows up, right? And the storage of this in a single machine is little difficult. That is the reason it is not preferred, right? The other solution, what Shubham was saying, was geohashing. Okay. So this is one of the popular technique, which kind of Redis provides a feature where basically this also lies on the similar lines only, but what happens is, uh, it also converts somewhere like this only, right? I'll leave this to you to read, right? How geohashing works, right? But understand the idea. The concept is same, right? The concept is same, that given a cell ID, right, you would get the nearby cell IDs as well by prefixing or by removing one of the two bits, right? But how it is better is that you're not storing the entire quad tree, right? What you're doing is, it is basically somewhere sharded in such a way that your request comes in, right? I mean, different these hashes are kind of sharded. Okay, it is kind of hash map, right? So you say that, okay, my user is at the location x comma y. Give me a 32 bit, right? And then what I will do is, I will search in that hash map, and search in the hash map with the nearby IDs. So I mean, the concept lies on those lines, basically. I mean, if Shubham, if you want to add anything, you can add here.
Yeah, that's pretty much it. So basically, the idea is like all your drivers and you are basically, or everyone is sharing the same geohash, and that's how it's very easy and fast to locate a driver around you.
Not correct. Same geohash, or the nearby geohash as well.
I think same geohash, because if we again go in a loop of nearby geohash, then we're increasing the complexity
No, no,
instead
no.
of
Because, see,
going to.
because now what happens is, when you say when same geohash, meaning that I may be at a distance X, right? And the driver there, I don't have any drivers nearby, right? Then I will never get drivers who matching mine, right? Because they might be some 2 kilometers away, and his geohash would be different.
Correct. So, I mean, please add it. I mean, as far as I knew, it was we defined the algorithm in such a way that we consider the radius of it in likewise, like 2
Whatever
kilometers.
you
3
do, so
kilometers.
guys, whatever you do, right? I mean, there will be some boundary, right? If
Correct.
these lines have let's say if these lines have some geo hash, right? Let's say if you say that there is one geo hash here and you are standing here, the driver the driver may be in a different geo hash, right? So what you need is you basically this geo hash and the nearby geo hashes. Okay, so that's how we will find out. Okay, so this is another technique which was used, but now even this is moved on. They have moved on from this, and there is something called H3. Okay, so this is again on a similar lines of what quadri and geohash is, but important thing that I understood was that these were somewhere taking the structure to be somewhere square, but in case of H3, what happens is all these regions, right, are considered to be hexagonal. Okay, so if you want to search on Uber blog, right, Uber H3 database, right? So they've open sourced also sometime back. Okay, you can go through this, right? There are multiple videos on it. I saw some video which was of 26 minutes. You can go through them and understand what H3 does. But what I found is it creates some indexes and these are all divided into some similar cells like this, right? So ultimately what happens is, let's say if the user is here, it actually gets the 7 cells, nearby 7 cells, and get the drivers in these 7 cells. Yeah. Okay. I mean, we really need not to jump too much into it, right? Because this is very specific to Uber, but understand that there exists a solution. Yes, you can dig deep offline, more read these articles, and come up with your understanding in the code. Yeah. Cool. So yeah, we were discussing the ride matching service. These are the 3 solutions.
I think just one thing, the resolution of this the H3 is also the same problem, aren't we going into that we had with Quadri?
I really do not have much clarity into it, right? But to be honest, this is not with the quad three lines, but this is with on the lines of geohashing, right? What I know is geohashing is 32 bits, right? That's how it is represented, and this is somewhere represented into 64 bits. Okay, so the two-dimensional coordinates, right, converts to a single dimensional string.
Correct. So actually in S3 there is a concept of resolution. So when you say 3, I mean if we don't get the driver in the first cell, we increase the resolution, we go into 7 cells, and then again we increase the resolution and we go into again neighboring cells.
Correct. That we can do. Yeah, that we can do. Yeah,
So
I think that would be the ideal way of doing it. Because
going
in sparsely located cities, right? I mean, obviously there would be a limit. Let's say we won't go beyond 10 kilometers, right? But as per this diagram, yes, what Shubham is saying is like probably this is where if we are getting the drivers, yes, good. If we don't get any results, then we go to this nearby, and then if we don't get here as well, then another kind of we kind of scale the area basically. Yeah. Okay, cool. Now, yeah, so we have 3 solutions, quadri, geohashing, and H3. We assume that we will be using H3, and that is somewhere based on geohashing itself, right? And every location is kind of represented by a 64-bit, and we would get to know that by removing some bits that okay, these are my neighboring cells. Okay. Now, if we come here, right? So what would happen is this right matching service, right? This will have to be kind of somewhere expanded. Okay. Okay. I see I lost my audience since it got lengthier. Okay, I'll not include the load balancer, right? But what will happen is we'll also have to have a routing service here somewhere. Okay. Now, what this routing service is basically doing is when you are kind of requesting a ride, right? Okay. Now, instead of when this user is requesting for a ride, what happens is this user gets connected to the system through a. I'll not talk about the long polling one, guys. I'm skipping that. Okay. This user would connect to this routing service through a WebSocket connection, right? And then what happens is this will send a request to the ride matching service, okay, for that get me all the drivers in the nearby area, right? And that's where this database would come in. Okay, that's where this database would come in. And now what DB it should be and how it should be sharded, right? All of that is a question, right? Probably what we can do here. Let's say this is a user DB, right? One would be a user DB, right? And another would be a what? I can say that user ID to location, correct? Yeah. Yeah. So now this would be another DB that will have to store user ID to location. Now what happens is once I this ride matching service gives me the nearby cells, right? I'll have to query this database saying that with these set of location IDs, right? When I say location IDs, the cell IDs, right? Or that are kind of queried here, okay? And we would get those users and we would return to the ride matching service, right? Now what ride matching service has is ride matching service has all the set of user IDs, that means the driver IDs, right? Which it has to paginate, right? Paginate in the sense it has to send the notification. So basically this ride matching service will have to again, then what have to do is basically send a request to this notification service with user ID, let's say this, and some trip information or whatever you say. Okay. When I say trip information, like start and location and all of that, right? And this car driver gets the notification, right? And if he accepts or rejects based on it, right? This ride matching service would kind of now if he, let's say, accepts, then this routing service comes in, right? And then it will have to call a API call accept trip, right? And that will basically somewhere what was that service? Accept service would be part of what? Okay, we'll have to have another service probably. Okay, we can't have this in the right matching service because we'll be bloating this, or let's say a trip service or something, right? Okay. Now let's say this guy says accept the ride, right? Accept the ride. Now what happens is this will put this into some queue, let's say. Okay, it puts into that queue. Okay, and now what happens? It will detect saying that, okay, this guy has kind of accepted the trip, right? Let me update the trip DB, right? Or yes, there would be a trip DB as well, right? And stop for this trip sending multiple notifications to the drivers. The flow would be something on these lines. Anything else, guys, here? I'm rushing actually. Any questions? Any questions here? Okay. In the interest of time, I'll not go dig deeper. There are some issues here, right? You can kind of spend time, right, and correct it. Okay. But then we'll go with other services, right? User service will be accepting the rating and all of that. Notification we will be kind of we have already used, right? In case of ride matching service for sending the notification, you can call out saying that Apple notification service is used in case of sending the notifications to the Apple users, right? Because the system already has the information that this device is connected via the Apple or the Android, right? Otherwise, Firebase is the service which is used for sending the notifications to the Android users. Okay. Anything else that we want to cover quickly?
Thanks, Pratik. I think we covered everything. Just one thing, I think when we are accepting the match, no, I think that transaction needs to be very crucial because based on that only my other requests will be failing. So I think that we have to do it atomically
Which one?
when we are accepting the ride, actually.
Or when we're
Because-
accepting the ride, right?
So that is a very crucial and atomic transaction we have to do.
Oh, yes, that's what I wanted to even go dig deeper because there can be some consistency issues, right? So
Correct,
what
correct.
can happen is so let's say there was one request that had gone to the first driver. Okay. So now by the time this accepts, okay, and through Kafka it comes in, correct? But in the meantime, this ride matching service has actually sent the request to the rider too, right? Okay. So then that's a problem actually.
Do we really need a Kafka here or some locking system, locking mechanism?
So
As well?
So what happens is instead of Kafka ride, what we can probably do is that this ride matching service before it sends to the other user, right? Probably we can include the Redis, right? And once this is accepted, we can make an entry saying for this trip, this driver is assigned, right? So before this ride matching service actually sends to another driver the notification, it will check. I just want to confirm. I mean, is this ride already accepted by some driver? Then, if yes, then it will stop there itself.
Yeah, like we can do it like when it's a transaction is done, we can change the status of the driver to be something assigned something
Right,
or a
right.
rider
That
is
is
assigned.
also very important. Okay, one important note thing that I wanted to send was that let's say when this user is actually when this driver was sent a notification, right? Okay, at that point of time, we'll have to change his status saying that the ride request sent, right? So that what happens is if any other ride that comes in, right, it should not, this user should not be even, this driver should not be again paged for that same for another ride.
Okay.
And that also will have to do that distributed locking through the Redis only.
Correct, correct.
Okay, so these are very important things. Okay, there are multiple other things that we wanted to discuss, but we'll wrap it here in the interest of time, guys. Any questions? I'll stop the recording.